Hey, Mr. Lee here. Let's graph some exponential functions, okay? Um, my method here is going to be utilizing a table, right? We're going to be given an equation. I'm going to utilize a table and then match some points on the graphs, okay? So let's get it started. Here is our parent function they give us. So this is what 1/2 to the power of x looks like. And it asks which of the following is the graph of all this. Okay, so yes, you can type it in the Desmos and get the graph right away, but for learning purposes, I really want you guys to see where the values come from, right? So equation, table, graph. 1/2 is not the nicest number to work with, but I'll give you some tips on how to work with it. Okay, so let's choose 0 as our first x value. Okay, so we're trying to graph this equation right here. And 0 is always a good exponent to choose because anything power of 0 is just going to be 1, right? So let me write this all out. -3 times 1/2 to the power of 0 plus 5. Okay, so the reason this becomes a nice number of 2 is because anything raised to the power of zeros is going to be 1. So this is the same thing as what? A -3 times a 1, which is a -3, and then -3 plus 5 is a 2, right? All of this just turns into the 1. -3 times 1, -3. -3 plus 5, 2, okay? So that means when I chose an x value of 0, I got a y value of 2. Okay, let's start with 2 points. We do have a multiple choice aspect here, so we're going to get 2 nice points and then see if we can do some process of elimination. Okay, so the 1/2 is hard to deal with. I'm going to show you why I don't like to use 1. Okay, so I'm going to give you a wrong, not a wrong, but I'm going to give you a more difficult x value to choose because it'll let you learn about which values are more convenient to use with this 1/2 base. Okay, so if I do a power of 1, look at what we get. I'm not going to get a nice number. Okay, it's not that horrible, right? But it's a 3.5, which we don't want to deal with necessarily. Okay, it still exists, right? You can put that on the graph here. But then imagine you're doing this in your head, right? Or you don't have a graphing calculator in front of you. Like doing 1/2 to the power of anything is going to be a lot more difficult. Okay, so what I recommend actually is using a -1. Okay, this might seem weird, but if you use a -1, this is what happens. Okay, if you use a -1, we get a nice whole number here. And the reason is because if you do 1/2 to the -1 power, you take the reciprocal of 1/2, which is 2, and then raise it to the positive 1 power, right? This is the same thing as writing 2 to the power of 1, right? I take the reciprocal of 1/2, which is a 2. This is one of your exponent properties. And because I took the reciprocal, I can then change the power to its opposite sign, right? It works with anything. Look, 1/2 to the -2 is going to be the same thing as 2 to the power of positive 2. 1/2 to the -5 is the same thing as 2 to the power of positive 5, right? So with these fraction bases, it's actually convenient to try to get your exponent to be a negative number, okay, in order for the rest of the expression to turn out relatively nice. Okay, so what was our conclusion here? We plugged in x value -1. I'm going to get rid of this decimal, right? It still exists, but I'm going to get rid of it just for ease sake. We chose an x value -1, and then it all evaluated to a y value of -1. Okay. Let's just be a little bit more thorough here. 1/2 to -1 we said was a 2. So that's where we get -3 times 2. This becomes a -6. -6 plus 5, that's where your final -1 value comes from. Okay, so let's see which graph has these 2 points, 0, 2, -1, -1, right? If I'm trying to graph this and I found 2 points that exist on the table, they must also exist on the graph. So 0, comma 2. I can already eliminate A, right? This doesn't even have 0, 2. This one has 0, 2. Does it have negative 1, negative 1? Nope. So it has the 0, 2. Option B has the 0, 2, but it does not have the negative 1, negative 1. So I can also eliminate option B. It needs both of these points, right? Every single point on the table has to match any and every single point on the graph. So this one has 0, 2, and it looks like it has negative 1, negative 1. Okay, so I might have to check some other points, but only if option D also has these 2 points, which it does not. Okay, D does not have 0, comma 2, so I know that the only option by process of elimination is going to be C. Okay, if it's not multiple choice, what you'd have to know is your asymptote is a +5, right? Because you can think of like your default asymptote at y equals 0. And then if you have a transformation of a +5 right here, this is like your vertical translation, that means your asymptote also moves with it. Okay, so it's going to move up 5 with it. And we should be able to see that you have an asymptote at 5 here. Okay, so just commenting on some more accurate ways to graph, because I know multiple choice sometimes you can get away with the minimum here. Okay, but I think we will see one where we have to know everything. Good, yeah, so good. This is one where we have to know everything. I'm still going to use the equation table graph method, but because we're graphing by freehand, I mean, we have some help with this, with this program, but for the most part, we're graphing freehand. We have to know how to get the asymptote. Okay, so let me type in what we have here. This is 3 to the power of 4 minus x. I'm not going to show the graph here. +1, right? I'm just using this as a calculator to organize my table. Okay, so this is where I'm going to advise you guys to analyze the exponent, right? This is a 4 minus x. So we can technically choose any number for x, but the nice numbers to pick is if we can get the exponent to be 0. Okay, so I'm going to show you a not so convenient number first, right? A lot of you will try 0 first, which I don't blame you for. If you do that, it's going to turn to this. Right? I plugged in an x value of 0 and I got a y value of 82. This number still exists, but we're not going to be able to graph it on here. Okay, so we're trying to get the exponent to be 0 versus just choosing the x value to be 0 itself. Okay, so let me show you what I mean. I'm going to erase this. Even though that point existed, we're not going to use it. I'm going to force the exponent to be a total of 0. So that means what I'm actually doing is I'm choosing an x value of 4. You guys see what I did there? So I chose an x value of 4. This becomes 4 minus 4 in the exponent. 4 minus 4 is a 0. Okay, so I chose an x value of 4 now. And this is the same thing now as 3 to the power of 0 plus 1. We know anything to the power of 0 is 1. That's why it turns into 1 plus 1. You guys see that? So the calculator shows you, what the calculation is, but I really want you guys to have an understanding of how you can also do this in your head. Okay. So final y value was a 2 here, 4 comma 2. Let's find one more. I'm just going to go 1 up. If I started at an x is 4, which forced the exponent to be a 0, I'm going to make the x value of 5 next, which actually I'm going to tell you that I regret because I went the other way, right? We have a 4 minus x here. Instead of a 4 minus 5, which gives us like a -1 power, not so nice with this base of 3, let's make it an x value of 3, right? So I'm making an adjustment here. But it shows you, like, you guys might experience this. This is good that I made this kind of, mistake. It's not really a mistake. It's just showing me that there's more convenient numbers to pick, right? But I chose a number that I thought was convenient, but then it wasn't. So then I go the other way and I kind of adjust my thinking, okay? So that's still a powerful tool. So let's choose an x value of 3 instead. So now I have 4 minus 3. It forces my exponent to be a 1, which is super nice, right? 3 to the power of 1 is just 3. That's why the final value is 4, okay? Okay, so this interactive, we just need 2 points. I'm going to deal with the asymptote later. 4 comma 2 is going to be right there, and then 3 comma 4 is right there. Okay, this isn't the final answer because we have to move our asymptote. The way you can find the asymptote is looking at the transformation shift, right? Your parent function, you can imagine, is going to be 3 to the power of x, right? Same base as the base of the equation we're trying to graph. This plus 1 is on the outside of the function, which means the vertical in translation plus 1. Your default asymptote for any exponential parent function is at y equals 0. It's already right here, right? Same as the x-axis. So if I shift everything with this plus 1 translation up, that means the asymptote moves with it, right? So that's how I know I have the most accurate graph, right? Any graph would be wrong even though I had these 2 correct points. These points are set, these are correct, but notice how this interactive is going to move all the other points on the graph in accordance with the asymptote. So I definitely need to move the asymptote there. Y equals 1. Now we should be good. Okay? Alrighty.